Assalamualaikum warahmatullahi wabarakatuh. My name is Nick Hairul Bin Fazil. My numeric number is BE20303. So for our group, I will start with question 1 simulation, which is, as you can see, which is I Roman, and for the 2 Roman, we will have to find del W over del R. So I use this is for question 1. So we put W equal to X square plus Y square plus Z square. So, and then A equal to del per del X, B equal to del per del Y, and C equal to del per del Z. After we put this, we will get a value A equal to 2X, B equal to 2Y, and C equal to 2Z. After that, we just continue on and put D equal to R multiplied by cos theta. We get the same as E equal to Q plus R square sin theta, and same goes for F. So after that, we continue with G equal to del per del R multiplied by D. We get G equal to cos theta. H equal to del per del R multiplied by E. We get H equal to 2Q R sin theta. And last, I equal to del per del R multiplied by F. And we got I equal to 0. So the last one, Fs equal to Ag plus Ph plus Cin. We got the final answer here. So for the next question, is suppose that z equal to fxy is implicitly defined as a function of x and y. Determine the z per del y for 4x square z3 minus 5y z square minus 3z equal to xy minus xy square. So after we put it in our mapper, we got it like this. So we must continue. A equal to del per del x, B equal to del per del y, and C equal to del per del z. After we put this, we got the value A equal to 8 at z3 minus y plus y square, B equal to negative 5 z3 minus x plus 2xy, and lastly, C equal to 12x square, z square minus 15yz square minus 3. For the answer, Fs equal to negative B per C, which we got this. For the next question is C. By using double integrals, determine the area of the region R enclosed by curve y equal to 5 minus x minus 1 square and line y equal to 2 plus x. So I use GeoGebra calculator square. At the first, we put in f y equal to 5 minus x plus 1 x minus 1 square, sorry, and then gs equal to 2 plus x and then we put intersection gf, a equal to negative 1 1, b equal to 2 and 4, and then a equal to x in sa equal to negative 1, b equal to xb equal to 2. C, we put in integral between FGAB, which we got 4.5. So as you can see, this is the graph that I got. For the second question, determine the surface area of the portion of the hemisphere with a radius of 2 that lies between the plane z equal to 0 and z equal to 1 in the first octant. So I also use GeoGebra suite. For the first, I put in f z equal to negative x square minus y square plus 4. G z equal to 0 and h z equal to 1. After we put in the input, this is what we got. So that's all for question 1. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Irshad Shahmi bin Susaini. My metric number is DE210109. Okay, I will continue about question 2. For question 2A, we use the GeoGebra 3D calculator. So firstly, we need to insert the equation from the question, which is x square plus z square equal to a square. So we insert it in here. So we get the graph like this, cylinder, and then we insert the y equal to x and y equal to 0. So we get the graph is like this. For question 2b, we need to find the volume of a curve which cut from a cylinder x minus 3 squared plus y squared equal to 9 when the z-plane is equal to 0 and y. We are using MATLAB for this question. So we get the x is equal to square root 9 minus y squared plus 3, and then y is equal to square root 9 minus x minus 3 squared. Then we need to run the simulation. We get the volume of curve which cut is 18 units. From the manual calculation also we get the volume is 18 units. Then for question 2c, we need to use spherical coordinate to evaluate the mass of solid below. And then we're also using the MATLAB. We get the z is equal to square root 8 minus x squared minus y squared. Then z is equal to square root x squared plus y squared. And x is equal to square root 4 minus y squared. And y is equal to 2. We need to clear the command window. Then run the simulation. Okay, we get the mass of evaluated solid is equal to negative 4 pi square root 2 minus 4 over 3. Then from the manual calculation also, we get the same answer, which is negative 4 pi square root 2 minus 4 over 3 units. So that's all for question 2 from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Syamsukaha. My number matric is BE20303. I'm from Group 5, Section 2. So today I'm going to show you the simulation video for the question 3B, C and D. For question 3B, we need to calculate the following line integrals in a counterclockwise direction around the triangle path as shown in figure Q3B. So the software that I use is MATLAB. This is the MATLAB software. For this question, what we need to do is first we need to find the dx/dt and the dy/dt for each C1, C2, and C3. How we gonna do it? I'll show you. So first is we need to display for C1 where the coordinate is 10 minus 00, and we will get the I. So this is the coding, and the dx/dt is 1, and the dy/dt for C1 is 0. It is the same answer that I get in the manual calculation. It's same goes for the C2 where we need to display the coordinate I2 minus I0, and we get the 2j, the coding, and the dx/dt for C2 and the dy/dt for C2 is 0 and 2. Same answer in the manual calculation. Next is the C3. We display the coordinate 0, 0, minus 1, 2, where we get the minus I, minus j, minus 2j. The dx/dt for C3 is minus 1, and the dy/dt for C3 is minus 2. Same that I get in the manual calculation. Next is we need to find the x to the power of 2y dx plus s dy in the counterclockwise for C1, C2, and C3. This is the coding that we get. For the C1 values is we get 0, same as the manual calculation. The coding for C2 and C3 is the same as the C1, but we need to change the C1 where if we need to find the C2, we change it to C2, and if we need to find the C3, we change it to the C3. So the value we get for C2 and C3 is 2 and minus 3 over 2. Same we get in the manual calculation, 2 minus 3 over 2. And finally, to find the final answer, CT, we need to add all the values C1, C2, and C3, where the final answer will be 1 over 2. Next is for question Q3C, where we need to calculate the following line integrals by using Green's theorem, where C is the path from 0, 0 to 1, 1 along the graph of y equal x to the power of 3, where y equal x to the power of 3 is the minimum value, and from 1, 1 to 0, 0 along the graph of y equal x, where y equal x is the maximum value. So we will use MATLAB again. So for this question, it's quite simple, where we need to put all the information given in the MATLAB software and go to coding, and we will get the answer where we will display the calculated line integral using Green's theorem, and we will get the answer 1 over 4, where this is the same answer that I get in the manual calculation, 1 over 4. Next is for question Q3D, where we need to find the work done by the force in moving an object from point negative 2, 4 to point 1, 1 along the curve y equal to x to the power of 2. So we will do in MATLAB. This question also quite simple, where we just need to put all the information given in the software and the coding, where we need to display the work done by force in moving an object. And the answer that we'll get in the software is 3. It is the same answer that we get in the manual calculation also, which is 3. That's all from me for this video simulation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syarul bin Zulkifli. My number is DE20106. So today I will present about the question 4A. So the question is calculate the surface integral. Double integral sigma y squared plus 2yz ds, where sigma is the first octant of the plane 2x plus y plus 2z equal to 6. So I do the simulation in the MATLAB software. So first we type this equation 2x plus y plus 2z equal to 6. Next we can build the 3D graph from this software, and we get this graph. Next we replace the value of y squared is a and 2yz is b. So the value of a is y squared, and the value of b is 2y times 3 minus x minus y over 2. And then we simplify the value of b, and we get negative y times negative x plus 2x plus y. And then we can expand this equation, and we get negative 2yx minus y squared plus 6y. Next, we find the value of ds. So we put into this formula, cert 1 plus negative 1 squared plus negative 1 over 2 squared. And then we get the value of ds is 3 over 2. Next, we need to do the integral of y. So the limit is 0 and 6 minus 2x. Y squared minus 2yx minus y squared plus 6y times 2 over 2 dy, 3 over 2 dy. And then we get the answer is negative 3x plus y times 6 minus 2x squared divided by 2. And then we integrate the value of x dx. So the limit is 0 and 3. So negative 3x plus 9 times negative 2x plus 6 squared over 2 dx. And finally, we get the answer is 243 over 2, which is same as our manual calculation, 243 over 2. So that's all for it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim Shahmi bin Muhammad Yusof. My matrix number is BE20303. Okay, so next is question B. Suppose that the surface of the sphere x squared plus y squared plus z squared equal to 4 is the standard deviation, and fxyz equal to 7xi minus zk. So the first question is find the divergence of f. Okay, from the manual calculation, the formula that we use is d over dx times 7x plus d over dy times 0 plus d over dz times negative z. Okay, so the value of 7x, 0 and negative z is from the question. Okay, so the answer that we get from the manual calculation is 6. So next we will go to Maple. Okay, so I will show you on how to do the divergence theorem in Maple. First, we have to click Restart to clear the previous memory. Then we call the vector calculus package. Okay, from the vector calculus package, the one that we will use is the divergence, which is here. Okay, next we will use the with plots package to find the field plot 3D. This is the one that we will use from this package. Okay, next we will set the coordinates to the Cartesian coordinates x, y, z. Okay, then we will define f, x, y, z using the function from Maple, which is the function we can get from the expression, which is this function. Okay, we will fill the value for x, y, z, which is 7x, 0 and negative z. Okay, then we will call back f, x, y, z. So the answer that we get from the Maple simulation is this. Okay, the ex is the unit vector for x axis and y axis. The ey is the unit vector for y axis and z axis. The ez is the unit vector for z axis and k axis. Okay, then we will plot the field plot 3D. Okay, so the graph that we get is this. So you can see from the simulation, we can see the 3D graph for this question. Okay, so the last one is we have to call back the divergent at x, y, z. Okay, from this simulation, the answer that we get is 6, similar with the manual calculation that we do.
So next is B2. So the question is evaluate the following surface integral by using Gauss theorem. Double integral sigma f times n ds. So I'm using Maple software 2. So first we input the value of x squared plus y squared plus z squared equal to 4. And then we get this 3D graph. The radius is 2. Next we take out the value of z and we put it outside. So it becomes x squared plus y squared minus 4 equal to negative z squared. And then we get the value of z equal to cert r squared minus 4, which is x squared plus y squared equal to r. And then we do the triple integral, which limit 0 to pi, 0 to, and negative cert r squared minus 4, and cert r squared minus 4, 6r dz dr d theta. And then we get the final answer is 64 pi, which is same as our manual calculation. So that's all for question B2. Thank you.
Okay, so next is question C. Verify the line integral and surface integral by relating them to the Stokes theorem, where C is the circle x squared plus y squared equal to 1 on xy plane with a counterclockwise orientation, breaking down the positive z axis. Okay, f equal to z squared I plus 2xj minus y cubed k. Okay, so we will go to Maple software. So I will show you on how to do the Stokes theorem using Maple software. Okay, so first this is the 2D graph for x squared plus y squared equal to 1. Okay, to find the left hand side, we have to call the x squared plus y squared equal to r squared. Then we have to find r equal to 1. Okay, then we will have to put x equal to r cos theta and y equal to r sin theta. Then we will have to define the f, x, y, z using the function from Maple, which we can use from expression, which is this function. Okay, the value of z squared plus 2x minus y cubed is the value of x, y, z or ijk that we get from the question. Okay, then we will have to define z squared I plus 2xj minus y cubed k for A, and dxi plus dyt plus dzk for B. Okay, then we will have to integrate the answer that we get, which is z squared dx plus 2x dy minus y cubed dz. So the answer of the integration that we get is 2xy. Then we have to define that dy over d theta is equal to cos theta. Okay, next we will have to integrate the 2 cos theta times cos theta d theta. Okay, from the integration, we will get the answer of 2 pi for the left hand side. Okay, next for the right hand side, first we have to call restart to clear the previous memory. Then we will have to call the vector calculus, which is from this package we will use the dot product, which is here. Okay, then we will have to call the with plots package, which the one that we use is the field plot 3D, which is here. Okay, so then the 3D graph for 1 minus x squared minus y squared is this graph. So as you can see from the software, we can see the scale of the graph. Then we will have to set coordinate to the Cartesian coordinate x, y, z. Next, we will have to define the f, x, y, z using the function from Maple software. Then we will have to call back the f, x, y, z, which is the answer that we get from the software is z squared ex plus 2x ey plus negative y cubed ez, which is the ex is the unit vector for x axis and y axis, ey is the unit vector for y axis and z axis, and ez is the unit vector for z axis and k axis. Then we will have to do the field plot 3D for f, x, y, z. So this is the graph that we get from f, which is the field plot 3D. So here you can see the scale for the field plot 3df. Okay, next we will using the matrix function, and the answer that we will get is negative 3y squared I plus 2zj plus 2k. Okay, then we will have to call z equal to 1 minus x squared minus y squared, and we will have to define the dz over dx equal to negative 2x, and dz over dy equal to negative 2y. Okay, so next we will have to find n. Okay, to find n, we will put it into this formula, and this is the answer that we will get. Then we will have to define the negative 6 times r cos theta times r sin theta squared for A. And we will have to define the 4 times r sin theta times 1 plus 2 for B. Okay, so the answer that we will get, we will have to double integrate it, which is the answer is negative 6 r cos theta times r sin theta squared plus 4 times r sin theta times 1 plus 2 r dr d theta. Okay, so the answer for the double integration that we do is 2 pi, which is, this is the value for right hand side. Okay, so that's all for question C. Thank you.